Checking attendance. All right. Good morning, everyone.
Good morning.
I'm sharing my screen. Okay. All right. Here's the assignment I just finished grading, assignment 17. Any question? Anything I should go over? All right. Moving to our topic today, which is the standard library. We talked about two other libraries before, math library and the we went over the math library, which has these math function. You're supposed to remember these functions that are listed here in this math library. Even though the library has many more, these are necessary for this course and you need to remember them. And you use them in the last assignment. The I/O manip library allows you to manipulate the output, basically. It allows you to control the output by using three functions. We went over them in the last class. And so now the third library, we only need to go over these three libraries. The third one is the standard library. It's called standard library, but the official name for the library file is stdlib.h. So the .h stands for header file. All the library files are defined as header files. So you have to type in this exact name, count include stdlib.h at the top of the program. If you do that, then you have access to all the functions in this library.
Professor, when I was doing the homework last night, I noticed that there's one for pi in the math library. So like instead of typing out 3.1415, you can just type in like m_space pi and it would just give you pi.
Yes, you can use the pi that's there in the math.
Okay.
Yes.
Gotcha.
In the future. But in the past, we didn't have these functions. Abs is a function that finds absolute value of a number. Now, you learned in the math library, there's a function called fabs. I don't know why they put that in math library and this in the standard library. I don't know why, but this is also finding absolute value, but this is good for absolute value of integers. Fabs is good for absolute value of floating point numbers. The F stands for float. Fabs means float apps. Apps means integer apps. You cannot use the wrong function. If you have integer number, then you want to call this function to find the absolute value. If you have a float type number, you have to use fabs to find the absolute value. Otherwise, the function will convert your number. You don't want to convert. But we will not run into finding absolute value. That's, I just wanted you to know. If you need to use it, that function is there. But our main focus is on this function, rand. Rand function generates a pseudo-random number. I'll explain why it's called pseudo-random number. A strand is related to rand, and we will understand that later after we start using rand. So what is rand function? Simply by calling this function, you will be getting a random number. totally random number will be generated by that function. Why is generating random number important? Because it helps you write simulation program. You may have heard of simulation programming. It means creating something, something that happens in life, you can recreate in the computer. That's called simulation. And the entire idea of game originated from simulation, and now the game programming uses RAND function all the time throughout. And we are going to learn in this class just simple applications of the RAND function. Simple simulations, that's what we're going to do. The RAND function generates a random number, totally random number in the range of 0 to the largest number your computer can handle. It'll be in that range. So it can be a very large number or a very small number. You have no control over it. The largest number your computer can handle is different from computer to computer, depending on the size of the computer. So this variable has that. This is a variable defined in the std library, and in any computer, after including this library, if you just see out rand max, that will print the largest number your computer can handle. That is a constant that has that number. It can find that number from your system, from your computer. But you don't need to find that number. In case you're curious, you can find out what it is. But to be able to write the program, you don't need to know what the largest number is, but it'll be a very large number. So the random number generated by RAND function is going to be totally random number in a very large range. That's not useful. Very often we need to bring the number down to a size. For example, if I want to simulate tossing a die, I can do that with the RAND function. But if I simply call RAND function, it's not going to give me a number in the range 1 to 6. It's going to give me a very large number. So how do I generate random number in a limited range? You're going to see that next. I can do Modulus Operator. If I do rand modulus 2, then my number is going to be remainder of dividing by 2. The rand will generate a large number, no matter how big it is. When you take modulus 2, you're bringing it down to 0 and 1, because the remainder of dividing by 2, the remainder of dividing any number by 2 will be 0 or 1. So you can limit the range by using Modulus Operator. That's how it's done. It's done all the time. Even if you open up a game program, you're going to see these modulus with the rand everywhere. So if I want to simulate tossing a die, then I have to limit it to 1 to 6, right? The rand, I need to generate, tossing a die is same as getting a random number in the range 1 to 6. That's all it is. If the die is actually, die has equally likely faces, then when you throw it, it's going to give you a totally random number in the range 1 to 6. So we can simulate that in the computer by generating a random number in the range 1 to 6. So if I do rand modulus 6, that's going to give me 0 to 5. The remainder is always going to be less than the number you're taking modulus with. So it will be 0 to 5 will be the range. So if I want to change the range to 1 to 6 instead of 0 to 5, I can add a 1. If I just add a 1, then the 0 to 5 now changes to 1 to 6. If you want to change it to 2 to 7, then you add 2. Just add 2 here, then it'll be 2 to 7. So that by manipulating this modulus and adding a number to it, we can change the range to any range we want. So for example, if I want to go from 2 to 6, then I can say rand modulus 5 plus 2. Rand modulus 5 will give you 0 to 4 range. If you add 2, then it becomes 2 to 6. The range is shifted to 2 to 6. Okay, so how do we figure out what number to do modulus with? It would work this way. you take this 5 and subtract this number 2, you get 3, and add 1. So 5 minus 2 plus 1 is 4. If I want to, I'm sorry, that's not a good example. So let me put it on the board, a different example. Suppose that I want random numbers in the range. So, okay, suppose that random number in the range of 5 to 16. Let's say that's the range I want. Then how do I figure out the number to do modulus with? If you take 16 minus 5, 16 minus 5, that's equal to 11. Add 1, you get 12. That 12 is your magic number. If you do rand modulus 12, that's going to be giving you 0 to 11, right? I'm adding 5. When I add 5, it shifts to 5 to 16. 11 plus 5, 16. So to get 5 to 16, the modulus number is 12. So to figure out this number, you basically do 16 minus 5, which is 11, add 1, 12. That's the number. So that's my formula right here, shown at the bottom. N minus m plus 1. To get the random numbers in the range m and n, you do n minus m, the larger or the right end of the range minus left end of the range, add 1, that number will work. And then the number you add is always the lower end of the range, like you can see. To get numbers in the range 1 to 6, I have to add 1, the bottom number 1. To get numbers to go from 2 to 6, the number I add is 2, because the rand always gives you, the rand modulus 5 gives you 0 to 4. So when you add 2, it'll go from 0 to 4 to 2 to 6. So the number you add is always the lower end of the range. So rand modulus n minus m plus 1 plus m is the formula. The right end minus left end plus 1. That'll give you the number to use. So let's do this exercise, and let me see if you can write your rand function call with a modulus to generate these. Put your answer in the chat.
Where do I find the PowerPoint, Professor?
I'm sorry?
Where do I find the PowerPoint?
On the website, Blackboard? I'm not understanding your question. The PowerPoint, you're talking about this presentation, where it is on the Blackboard? Is that the question?
On your Blackboard, where can I find this? Am I not seeing it properly?
All right, this presentation that I'm using right now, you want to know where to find it on Blackboard, right?
Yes. Where can I find this presentation on my free time? Yes.
If you go to the class number, today's class number is 23, right? Class number 23. So on the PowerPoint, if you go to the section on functions, which is functions topic, and go to the class 23 material. The class 23 material is this PowerPoint presentation. So if you just click at that link, the line that says class 23 material, that is the link to this presentation. Okay.
Thank you.
Mhm. Brandon, did you get my message about the meeting?
You said me?
Yes, I sent you a message asking you to meet with me and read that mail.
Meeting.
If that time is not good, I can set up a different time, but you need to reply that message.
When did you send the email?
I sent that yesterday.
1 second. 1 second.
Hey, Professor, did you see my email? I sent it to you yesterday.
Yes, about the exam. I cannot tell you exactly which day it is, but it'll be either the class before last class, which is going to be, I think, 12th, or the last class, which is 17th. That's all I can tell you.
So you did the 12th or the 17th is what you're saying?
17th, yes.
Gotcha.
Put your answer on the chat. All three or one, whichever you can do quickly. You can put the answer in the chat. Okay, I have +10 0. When you don't need to add anything, you don't need to put +0. So let me see, 14 + 3. Yeah, okay, Michael has everything right. Yeah, Marco has everything right. Gabriel answered the first one, which is correct.
Professor, you did not email me, sir.
Oh,
I'm looking at my Gmail and my John Jay email right now, Professor. You did not email me.
okay.
That's the wrong person.
Sorry. Yeah, I may be referring to the wrong person.
Yeah, I know.
No, I meant to write to you. I may have written to wrong person then. Can you meet with me today at 2 o'clock using my old office hour link?
About what,
Okay, Brandon.
I hear you, but what is the meeting about, sir?
I'll tell you when we meet. Use the old link for the one at 2 o'clock with I had for original office hours, which is not office hours anymore. Use that link. If you don't have it, it's there on the blackboard as one of the announcements.
Okay, sir.
All right. Okay, Christine has first two right, but third one is wrong. Let me go over all of them for everybody. The first one says 0 to 9. So to get 0 to 9, it's just modulus 10. Modulus 10 will give you 0 to 9 very clearly. That's easy. So for the part A, it's rand modulus 10. For part B, it's you are going 1 to 10. That means you had to go 11, rand modulus 11. I'm sorry, rand modulus 9 will give you 0 to 8. You need to go 1 to 10. So rand modulus 10, sorry. The modulus 10 will give you 0 to 9. And if you add 1, it'll shift to 1 to 11, 1 to 10. So rand modulus 10 plus 1 is the answer for second one. But you can also use my formula that I explained. 10 minus 1 is 9, plus 1 is 10. So that's why this 10 will work. Okay, part C, rand modulus. To find this number, you can do 16 minus 3, which is 13, add 1, 14. The 14 will what? 14 plus 1. So rand modulus 14 will give you 0 to 13 when you, I'm sorry, add 3. When you add 3, it'll go 3 to 16. So range is 3 to 16. All right, moving on. Here is the, so why do we need this rand function? We're going to simulate the actual real life experiments, such as tossing die many times. I can simulate that in a computer program. I can have the computer toss the die for me and write the results of tossing the die. So that's what simulation is. We're going to do simple simulations like tossing die and tossing coin and things like that. But it has advanced application of simulating all kinds of real life things. But we are only ready for simple applications. So in the next program, I'm going to simulate tossing a coin many times. So this is going to, I'm going to write a program that will toss a coin 10 times and write H or T showing head and tail. So to get head and tail means, or toss a coin means getting only 2 random numbers. Getting a random number in the range 0 to 1. So that would be same as simulating tossing a coin. Okay, so when you toss the to toss the coin, basically I just have to do rand modulus 2. Rand modulus 2 will give you 0 or 1, only one of 2 numbers, and you can interpret the 0 as head or 1 as head. It really doesn't matter because the whole thing is random anyway. So here's the program. I is used to count. I need to count how many times my loop goes so that I is going to control the loop. That's all I is going to do. The phase is where I store the phase of the coin. So while I less than equal to 10, that means I'm saying repeat this 10 times because that's what I need to do. I toss the coin 10 times. So here's where I'm tossing the coin. Phase equal to rand modulus 2. That's right there is tossing coin. And the result of that toss is stored in phase, and it will be 0 or 1. So I say if phase is 0, C out H means I'm interpreting 0 as head, else write T, interpreting 1 as tail. You can interpret the other way around, doesn't matter, because this whole thing is random anyway. So, and then, so that's all I need to do, if else, and then increase the I so that the loop will go 10 times and it will write H and T 10 times. So if you toss the coin 10 times, you expect to see H and T 10 of them. And that's exactly what you get. This is the actual outcome produced by this program. Random arrangement of H's and T's. So that's how you simulate tossing a coin. Let's now understand why, what is srand function? Srand function is needed for the following reason. Let me go back to this program, the previous program. If you run this, so when you run this program, you are calling the rand function 10 times. So the rand function will produce totally random number each time. And so that's going to be, so this will work fine. Rand function will produce different random number every time you call that function within the program. But one thing you need to understand is if you run this program again, if I execute this program second time, re-execute the program, then you would expect different arrangements of H and T's, right? You expect the random number to be different when you execute again. But the designers of the rand function decided not to do that. So when you re-execute this program, your output is going to be exactly same as this. This is exactly what you're going to get. Why? Because during re-execution, rand function is going to produce exact same random numbers it produced the first time. It's not going to change. The reason why they did that is if rand function works that way, then it's easier to fix problems because if it is producing the same random numbers when you execute again and again, it'll be much easier to find the errors in the program. Not this kind of program. This is very elementary programming with the rand function. But in advanced programming, if the rand function keeps generating new different numbers, new random numbers every time you re-execute, then finding errors becomes difficult, errors in the program. So therefore, they designed the rand function to produce exact same random numbers when you re-execute. That way, fixing the errors will be easier in advanced programming. So therefore, they decided to provide another function to control the randomness of this function rand. In other words, how random you want them to be. If you want them to be a different random number when you re-execute, then you need to use the strand function. So here is how a strand function works. You just throw in a strand function within the program somewhere. Normally we write it at the top, and then provide a seed. So like this. If I write srand and write a number inside 2, semicolon. Just have to write this somewhere in the program. We don't normally write it in the body of the program. We write it at the top so that it's clear for a reader where the strand is. And this 2 here is called the seed. And basically, if you plant a different seed, you get different plant. And that's the idea for calling this a seed. If I keep this number 2 the same, the program will, the rand function within that program will produce same random number. And if I change this to 3 and re-execute the program, now the rand function will generate different numbers. And if I change the seed again, then the rand function will generate different numbers. So that's how you control it. So if you just don't write, if you don't write the strand function, or if you write the strand and keep the seed the same, then rand function will generate exact same random numbers. If you change the seed, then it will produce different random numbers. So that's how it goes. So, but if you sell this program, you just say you generate a marketable software and you want to market it, then what these professional programmers do is when you market the product, the buyers, when they use them, they expect the rand function to generate different random number every time you re-execute. Otherwise, it's not going to work for them. So what the professional programmers do is they throw in the srand function with a seed that will always change. The seed they use commonly is time 0. The time is a function that will find the time from the clock built into the computer. And so time 0 is the function. You had to pass the 0 to that function. It will find the time from the clock, and you're using that time as your seed. So the time is always different. Every time the function is re-executed, the time is going to be different. So the seed will be different. So that's something, only professional programmers have to worry about. But when you write your program in your homework or project, you don't have to worry about srand. We are only practicing. We don't care about generating new random numbers every time we re-execute. in fact, if it keeps doing the same, keeps generating the same random numbers, it will be easier for us to fix the problems in the program. So you don't have to worry about SRAND at all, but you need to know what that is, and that's why I explained it. All right, so moving to the next example, I'm going to now simulate tossing a die. Our goal next is to understand or determine exactly how many times the number 1 will show and how many times number 2 will show, and so on. If I toss the die 6,000 times, I want to toss the die 6,000 times and see how many times each outcome will show up. So if I, instead of sitting down and tossing a die 6,000 times, I can have it simulated in the computer program and have the computer do that tossing. So here's how it works. You need the IO stream for every program. You need to include that library for input-output. That's where the C in, C out are defined. So your C in statements, C out statements can be used only if you include that library. And IO manip is included because I'm using the output control set width function. And stdlib is where the rand function is. So I had to include that to be able to use rand function. And in the main, I declare my counter. To control the loop, I need the I. And then phase is where I'm going to store the phase of the die after tossing it. Count 1, count 2 are used to count how many times 1, 2, 3, 4, all those numbers showed up. And they all have to start at 0. I'm setting this SRAN to have a seed of 1. Now, like I said, you don't need to do that. If you don't have SRAN, it'll work fine. But the rand function will be generating same random number every time you re-execute. And that doesn't matter to us. So you don't need to use SRAN. Now, since I need to toss the die 6,000 times, I'm saying for I going from 1 to 6,000, incrementing by 1 each time, phase equal to rand modulus 6 plus 1. That's where I'm tossing the die. Rand modulus 6 plus 1 will generate a random number in the range 1 to 6, and that means tossing a die. And I'm storing the result in the variable phase. And then if phase is 1, increase counter 1. If phase is 2, increase counter 2, and so on. So whatever the phase is, it'll cause incrementing one of the counters. And this is being done 6,000 times. So the computer will toss the die 6,000 times, and it'll count how many times each number showed up. And all I have to do next is print those numbers. So I'm printing those results. And notice the way I'm using set width function here. After writing the heading of the columns, I want to put 2 column output. After the heading of phase, I want to write the heading frequency. I want to have certain number of spaces in between. Now, to have spaces in between, previously we used tab. You can use tab, no problem, but tab doesn't give you control on how many spaces are going to be there between the 2 columns. But you can control it by using set width. I'm setting set width 13. That means after writing the word phase, use the next 13 spaces to write the word frequency. That's what I'm saying. But the frequency has 9 letters. So therefore, there will be 4 blanks in front of frequency because I'm using 13 spaces. So that gives you 4 spaces between the word phase and the word frequency, 4 spaces in between. So you can control exactly how many spaces you want between the titles.
And the set W, is that for the second library that you included? That's how you get that?
That's in the that's in this IO manipulator.
Yeah, that's the second one. Okay, gotcha.
That's what we went over in the last class. So by using set width, I can set exactly how many spaces I want between the 2 titles, and that's the power of these functions. And by using the same set width, I can make sure these numbers are going to go under the titles. I put blanks in front of 1 so that 1 will go into the middle. And then by using set width 13, same set width 13, I'm making sure the count 1 will go under the title. So my output comes up this way. Each number showed up this many times. This is actual outcome from running that program. To toss the die, this is all you write. And if the problem says you need to toss the die twice, so I'm writing on the board, then just say phase 1 equal to rand modulus 6 plus 1. That's tossing the die once. And phase 2, in a different phase, you say rand modulus 6 plus 1. So you just do the rand modulus 6 plus 1 again. That will be tossing the die second time. In one of your homework problems, it tells you to toss the die twice. That means this is all you have to do. And then you're supposed to do, you're supposed to add the two phases. So sum equal to phase 1 plus phase 2. Now, phase 1 and phase 2 will be different. Within one execution of the program, rand function will generate different numbers. So phase 1 and phase 2 will be different numbers, and you're adding them. And then proceed to do whatever you need to do with that sum. Just wanted to give you that idea for the homework. Yeah, that's all there is in simulation. That's all the simulation we're going to do, tossing die and coin and stuff. We are not ready for advanced simulation. All right, moving on to references. References would be other names, multiple names for memory cells. That's what references are. A reference is another name for memory cell. And we can create them in C++ by doing simple declaration. So here I'm going to explain that. A reference to a variable is another name for the same memory cell it represents. So here's an example. If I declare int val equal to 7, then you have a memory cell with 7 stored in it, and it's named as val. Okay, so val is the name for the memory cell with 7 in it. And then if I want to declare a reference to that same memory cell, here's how I declare it. You use int and then make up the new name, and then set it equal to val. Int and num equal to val. This says num will be another name for the memory cell val, for the memory cell represented by val. So after that, the memory cell, same memory cell that had val as the name, now has num as another name. So you have two names for the same memory cell. That's all you have. The num is called the reference. So after this, if you change num, you're changing val. If you change val, you're changing num. Both are names for the same memory cell. So this int and operator is the declaration of reference. Just int will declare a variable, but int and makes it a name for another already declared memory cell. That's what that is. So you write it this way. Int and num equal to val means num will be another name, or num is a reference to val. It becomes another name. So to give you an example, let's say I say float x equal to 3.5. Then I'm writing on the board. If I say, so that variable x, let's say this is the memory cell x, 3.5 is stored in it. And after that, float and y equal to x. That means y is another name for the same memory. Now it says x equal to 2 times x. So that's doubling the memory of x. So 2 times 3.5 goes back in X, that's 7.0. So now you have 7.0 in this memory cell. So if you see out Y, you're going to get 7.0 because Y represents same memory that X represents. So whether you change Y or X, you are changing that memory. So that's the idea. Reference is another name. Okay, so it doesn't seem all that impressive, is it? I mean, why would you want to have two names for the same thing? Well, in normal programming, you don't need that. We never need to use that. But when it comes to functions, it's a powerful idea because let's go back to functions. Let's look at this simple example, square x. When I call the function square x, I'm passing the value x. X has 3.5. So the 3.5 will be basically copied. The x, when the x is passed into num will get a copy of that 3.5. So let me use the board. When you go to the function square, float square has float num as the parameter. And inside, the way we wrote the function square before was like declaring another float type variable, y, and storing num times num, which is the square. And then we return y. The value of y will be passed back to the main. That's how we wrote that. When the function call float, function call sq equal to square x, when this is executed, x already has 3.5. So what happens is when this statement is executed, 3.5 will be passed into here. A copy of 3.5 will be going into num. So num is another memory cell getting a copy of 3.5, and you're squaring the 3.5, storing it in y, which is another variable. Y has 3.5 squared. And then you're returning y. So when you come back, the entire square x has the answer, which is 3.5 squared, and that's being copied into square. That's how it worked, right? So that was the normal way the function worked. But I can write this function differently to eliminate this return altogether. If I use this idea of reference, here is how it works. I write the float square and float and num. If I do that, then I can do num times num here. And instead of returning, I can do a slightly different thing. Let me write a main program on the side, and then I'll be able to explain. In the main, I can write float x equal to 3.5, and then call the function square and pass x. And now I'm passing 3.5, not by value, not a copy of 3.5, because the x is now passed into num, but I declared num as a reference. What that means is the x was declared in the main, and it had a 3.5 in it. And now I'm passing this name x into this reference. That means the num temporarily becomes another name for the x. That's what happens. So num becomes another name for the same memory x. And so when I multiply num times num, I'm multiplying 3.5 times 3.5 that is stored in x. And I can even put that answer back in num. And that means I'm putting the answer 3.5 squared in num, which is let's say it's 15.5. I don't want to find the exact value. So if 3.5 squared is 15.5, and that goes into the same memory where 3.5 was. That's what I'm doing here. So after that, I don't even need a return statement because I don't have to return anything. When this bracket is hit, it will return to the main. When you come back here, the X itself has the answer. You didn't send a copy, you send an access to the original value X, original value of X. So therefore, the function was able to use that X, the value of X, to produce the square of it, and it has put the answer back in the same memory cell. So when you come back, your memory X has the answer. So I'm not doing SQ equal to square anymore because square is not bringing back anything. So simply make the call to the square, put semicolon. After that, variable X has the answer. C out X. Understand the difference now? The difference is your answer is carried back in the same variable where the original data was. Answer is put in that variable by the function. And that's a powerful idea because the function can return, the return statement can return only one answer. But this way, function can return many values to the main. Now, we don't need to do that in this course, but you will be doing it in advanced programming classes. So you can use this reference idea to be able to carry many values back to the main rather than one value back to the main. So that's one of the reasons. And we are going to be using references in many ways as we proceed. So you will understand it better after that. The reference is a very useful idea in functions because you are giving access to the function to an original memory rather than giving a copy. You're allowing the function to work on your original memory, and that's sometimes necessary, as the next example will illustrate why it is necessary. We're going to see that in the swap example. So let's go to the swap example. If you remember, swapping two memory cells is something we did as exercise when we were learning chapter 1. That swap is an important thing in the next chapter coming up. And so let's practice with that same function. If I write swap as a function, and the goal is to have this function swap the two memory cells that I have values stored in. And why is the swapping important? You will see that when we do some serious exercises in chapter 6. So here's our goal. I have 23 and 35 stored in these two memory cells, and function swap is going to swap them. So if I call the function swap, after this call is made, the N1 and N2 should have the two values swapped. And so if I print N1 and N2 afterwards, it should be 35 first and 23 next because they're supposed to be swapped. So how does the swap function work? It receives the 23 and 35. Oops, that was done in the exercise. Okay, swap receives the values 23 and 35 in the names A and B. Okay, so let me go to the board and show you what that will be. Here's A and B, and they have 23 copied. A has 23 copied, B has 35 copied. But the original memory cells of the program, in the main program, were N1, 23, and N2 was 35. And so you wanted these two values to be swapped by the swap function. So let's go to the swap function. It has variable AB holding those values. to swap, we learned the method. It is, you need another variable name to hold one of the values. And here I'm declaring val for that. So here, int val, and then val equal to a. I'm copying one of the values in val. So val is getting a copy of a. So 23 is copied. This value is copied here. And after that, you can copy the b into a, erasing the 23, because you have already saved 23. So 35 is now going here. And after that, you copy the 23 into this, erasing 35. So now you have 23 here. So you have swapped them. That's the idea. Okay, so it does swap val equal to a. After that, you copy b into a, and then you copy val into the b, and the swapping is done. If you actually execute this program, are we going to get 23 and 35 swapped? And if they are swapped, then this program will print 35 and 23 in that order. Is that going to happen? No. Why not?
Because you don't have another variable.
You don't have what?
Another variable to store the swap.
Oh, no, I am doing it in the function swap. I am using a int val declared, and then I'm copying a into val. That's exactly what I showed you on the board. A is being copied into val, the 23. After that, val is copied here, and I mean, A is copied into val, then you copy the 35 into this, so you have 35 here. After that, you copy 23 into this, 23 is here now, erasing 35. So it looks like it's swapped. So function swap is actually doing the swapping. So why are we not getting the N1 and N2 swapped?
There's no return or
Uh,
variable.
There is no return. Yes, there is nothing to return. You're supposed to swap the two memory cells, and that's what it's doing. There's nothing else to return.
But doesn't it have to have the and?
That's right. You're going to the answer, but the point is this. I think you got the point, but you didn't. You're expressing differently. The point is this. When I pass the N1 and N2 to the function swap, I'm only passing a copy of N1 and N2 to go into A and B. So 23 was copied into A and 35 was copied into B. And then only the copy is being swapped by the function swap. And that's not changing N1 and N2. So this N1 still has 23, N2 still has 35. It's not swapping N1 and N2. It's only swapping the copies, right? That's not going to do the job. So what we really need is the function swap to swap the original memory cells N1 and N2. So how do I do that? What change do I make? I think Alexandra said it.
You have to put the and in front of A and in front of B.
Right. You need and A and B. You make them references. So now when you make them references, now when you run the program, you're not getting copies going into A and B. This is not happening anymore. Instead, A and B become new name for N1 and N2. And so when you're swapping A and B, you are actually swapping N1 and N2. So 35 goes here, 23 goes here. Now you're working with the original memory and swapping them. And so when you come back, N1 and N2 have been swapped. So all you need to do is just make a call to the swap and the job is done. If you see out after that, you are going to get the numbers reversed because now you are actually swapping the original memory. So you can see the need for the calling by reference method. The references are needed. You make them and A and B, then the function is allowed to access the original memory cells in the main program and work with them and do the job it needs to do on the original memory. And that's the power of the reference. It gives access, namely reference allows you to give access to the original memory cells to the function. Normally, functions don't get access to the original memory. They only get copies. So that's the power of the references. And so let's see one more example. I already explained all that. So let's see another example. Just to show you that you can, not this one, just to show you that you can avoid returning an answer. You can pass an answer back to the main program using one of the original memory cells in the original program. So I'm just showing a way of passing answer back to the main through the memory cell rather than return statement. So here I'm writing a function average to receive two values in references. It'll receive two values in references means it'll gain access to the original memory cells in the main program. And it'll name them as A and B temporarily and work with those A and B. So what am I doing with A and B? I'm finding the average of A and B and storing it in A. I'm not storing it in a local variable. I'm storing it in the parameter A itself. And then I'm returning nothing. You don't even have to write this return statement. When this bracket is executed, it will go back to the main. No need for a return statement because there's nothing I'm returning. I have all the answer is stored in A. And how does it work? Let me go to the board and show you. In the main program, N1 is 5.3, N2 is 7.5. So in the main program, there are two memory cells, N1 and N2. N1 has 5.3, N2 has 7.5. And then I'm calling swap, average and passing N1 and N2. So the N1 and N2 are going into the references A and B. That means A and B will become names for N1 and N2. A and B are names for these cells now. So A plus B over 2 means the original value is 5.3 plus 7.5 divided by 2 will be 6.4. And I'm putting that in A. That means I'm storing it here in this memory cell A. So this is getting the 6.4, the answer. The answer of average is going into A. B is not changed. So after that, when you, after this line is executed, you're returning to the main. When you return to the main, the variable N1 is where the answer is. N1 is MSA. It was MSA. While you are executing the function, the A and B become temporary names for N1 and N2. And when you leave the function, that name is gone. When you come back to the main program, you don't have those names A and B anymore, but the N1, the memory cell represented by N1 has the answer. So I see out N1. So the answer was carried back to the main in one of the original memory cells passed on to the function. And that is a nice way. And if I need to pass two numbers to the main, I could have, suppose that I need to not only put the average in one of them, and let's say I also need to find the difference between them and return that also. I mean, just to make an example. Then I can do B. I can do B equal to A minus B. The difference between the two variables is stored in B. So when you return here, N2 has the second answer, the difference between the two numbers. So you can pass many values back to the main by using this approach. That's why the references is a powerful tool.
And Professor, you could use the same average in the main program. Like the same name average when you're using like the difference?
Yes.
Okay.
So when you need to find the difference and average, you're finding both.
Mhm.
To find both, you're calling the average function.
Okay.
So when you return, N1 has the average, N2 has the difference.
Mhm.
So you're finding two answers by using one function call. That's right. So these are the advantages with the reference tool. When we proceed to chapter 6, you will see we will use these references very often. All right, so that finishes this entire chapter 5, and we're going to get started with the chapter 6 and do whatever we can. We can do part of it. So the arrays, that's our chapter 6, and that's our last chapter, by the way. Arrays is necessary. An array is necessary when you need to store multiple values in the memory. Now, why do we need that? Let's go back to problems we did in the last class. We did problems in which we needed to get a large number of data from the user. Like in this last project, you collected stock prices. So if there are 100 different prices available, and you need to analyze them and come to some conclusion as to whether to buy that stock or not, we needed to get all those 100 data from the user. The way we handled it was we took one data at a time. Take one data and do whatever you need to do, add it to the sum and compare it to the max and all those things you did within the loop. And then you went on to ask for the next data. When the user enters the next data, you do the same thing with the next data. So you were holding only one data at a time. That's how we did that in the last project. And now you can do that whenever you need to process the data one at a time, but you don't need to hold all of them in the memory. Then you can do it that way. So whenever we don't need to hold all of them, we do process the data that way. But sometimes we need to hold all of them. So for example, suppose that I want my grades in my class to be arranged in increasing order. So I want to write a program that can rearrange all of those numbers in increasing order. Then I have to provide all of the numbers to the program. The program has to have all of them available to be able to compare them all and rearrange. So all of the data are necessary in certain situations. So how do we store all of the data? If you store 200 data in 200 different memory cells using 200 different names, then even to add them up, you have to write a statement that'll have 200 variables or 201 variables. That itself is too much of typing for us. Now imagine handling 2,000 data. You can't finish writing one statement if you use 2,000 variables for them. So that's not the right way. You have to store them in a manageable way. And that's what arrays are. Arrays allow you to store multiple data under one name and then access them using what is called subscript. You can access one at a time or access all of them and do whatever the processing you need to do. So it allows you to manage thousands of data in an easier way than storing thousands of memory cells, thousands of variables. So we're going to understand how to declare the array and how to use the array in a program. So, all right, yeah, basically multiple memory cells will be named under one name, and it can be very large. And even if you have thousands or 2,000 data in that array, a simple 3-line loop can process the whole array because of the subscript idea. So let's understand how to work with them. If I declare a variable as num, then I can only store one number in it. I cannot store 200 different numbers. But I can declare num as an array, then I can store 200 numbers in it. And they all have to be same type though. So when you declare the array, all of the numbers are going to go into that same array. So they have to be of same type. Data type cannot be different for the data. Okay, so how do we, let's see how it works. If I declare an array num under the name num of size 5, if I tell the system the size is 5, then it'll give you 5 memory cells. And it will name them as num bracket 0. They all have this common name num with the additional subscript added to them. So very first cell in that 5-cell collection will be named as num bracket 0. Second one will be named as num bracket 1. Automatically, system will name them as num bracket 1, num bracket 2, 3, and 4. Notice that the last one is named as num 4, not 5, because the counting goes from 0 to 4, and we cannot change that. That's the way it works. So num 0 to num 4 are the names for the 5 memory cells. So if I want to access any one of them, I have to use that name with the number in bracket to access that cell. Okay, so another one, if I declare num as an array of size 10, then I'll get 10 memory cells. If it is declared as int type, then I get 4 bytes of memory for each one. If you remember, an int type variable gets 4 bytes. This is an int type array, so each memory cell, each of the 10 memory cells will get 4 bytes. So altogether, how many bytes are used up? There are 10 memory cells. Each one is of 4 byte size. So how many bytes are there?
40.
40 bytes. So it uses 40 bytes of memory. And the very first one is named as num0, and the last one is named as num9. You have to remember that it's last one is not num10, it's num9. Always one less than the location number. Second element of the array is named as num1. Third element, num2, and so on. That's an inconvenience, for programmers, but you cannot change that. That's the way it is. Okay, so let's answer these questions. I already asked the first one. Let's look at the second warm-up exercise. If you declare cval as an array of size 20 of char type, then what is the subscript value of the last element? The last element of the array will have what name or what subscript value?
Cval 19.
Cval 19 is the right answer. Okay, how many bytes of memory will this array take up? How many bytes of memory is taken up by one char type variable?
Four.
Char type,
1.
2.
1 byte, yes. Because character needs only 1 byte of memory, so each char type variable takes 1 byte. So this array takes how many bytes?
20.
20 bytes, right, very good. Okay, moving on. If I declare, how do I declare an array? I declare an array by specifying the type, like int, char, or float, and then a name. You have to make up a name. And then a bracket and size. This bracket and size is the one that makes this an array. If you don't put the bracket, it's a variable, right? It's a declaration of the variable. The bracket makes it an array. And in the bracket, you need to put the size. So if I need an array of size 200, I need to put 200 there. The size, what I have said as size here, cannot be a variable. It has to be a number. So like float val 200, this declares val as an array of size 200 of float type. So it can hold 200 floating point numbers. char cval15 can hold 15 character values. Long num100 can hold 100 numerical values, long type. Long is same as long int. Can I declare in num bracket with nothing in it? In certain circumstances, you can. I'll get to that later. But normally you cannot. You have to provide a number, a size inside the bracket. Okay, moving on to declaring an array. So here's an array declared as int num10. That means there are 10 elements in this array. And can I access each one individually? Yes, like this. Num0 equal to 15. Then I'm storing 15 in the very first cell in that array. You can imagine array as a sequence of many memory cells together. So very first cell is getting 15. Num2 is the third one. Remember, the location number 3 subscript number is one less. Third memory cell is getting 9 stored in it. Here I'm saying subtract the first memory cell minus third memory cell. Put the answer in the sixth memory cell. You can do that. So if you look at the picture, num0 has 15 here. Num2 has 9 there, and num5 has the difference between them, 15 minus 9. And going back to the statement, num6 equal to 2 times num2, take the third memory cell in the array, multiply by 2, and store it in the seventh. And that gives you 18 in the seventh memory cell. So these are valid statements. You can do that. But very rarely we write anything like this, because we don't store numbers in array to be able to do this kind of operation. We normally need to do the same kind of operation to all of them. So we do that in a loop. It's very convenient. In a 2-line loop, you can process an array of size 2000. But you know, in the way you want it. And normally what we want to do is kind of same thing, like adding up all of them. You can do that in one loop, add up all of the elements in the array. So loop is a common way of using it. So this kind of statement, even though they are valid, you know, you're dividing one of the elements by 15, 5, and storing it somewhere. These are all valid, but very rarely we do something like that. So let's go to the some more understanding of the array. We can start using array only in section 6.2. In 6.1, we are just understanding arrays. Cout num6, that's how you print one of the elements if you want to print one of them. Can I get data from user and store it in second element of the array? Yes, you can do that. C in num1 will store whatever the user enters into the second element of the array. And nothing, well, of course, you have to write C out. You have to tell the user that what a number is expected. And then you're reading it into one element of the array, which is valid. Now I want to show you that something like this is valid. You can say num bracket. Inside the bracket, I said you have to have a number. You don't have to have a number. You can have an expression like this, 4i minus 2. I is 2 in this case, so 4i minus 2 will be 6, 4 times 2 minus 2. And that 6 will be used as a subscript value. So instead of subscript value, giving an expression is valid. It's okay to do that. So now initializing an array at declaration. Okay, so remember we did with the variables like this, int m, and then we assign the value right there, 5 to it, and semicolon. Can we do that with arrays? You know, an array is going to be basically a large collection of memory cells. Can we store values in all of them in the declaration? That's what we're doing now. Yes, we can. Suppose that I need to store these numbers in an array. then there are 7 numbers. So I need an array of size 7. So I declare int num7. Now here the 7 is size of the array. Remember, that's not subscript. That's size of the array. So I'm saying num is an array of size 7. That's what I said here. And then if I assign 7 numbers in brackets, they will be assigned to the elements of the array. So 15 will go into the first elements, 20 will be in the second, and so on. And this is valid. So I can assign and at the declaration. Since I have 7 numbers here, it is okay to miss that 7 in the bracket here. If I miss it, compiler will figure it out. Compiler will actually use the count of this to make this array of size 7. So this is when you can miss a number in the bracket, when you're assigning the values. When you assign 7 values, the compiler can figure out there are 7. But if you are simply doing a declaration without assigning values, then you have to have a size number in the bracket. Otherwise, it'll be error. Okay, so more examples. If I want to declare an array to store the vowels, all of the vowels, I can do that. Char vowels equal to A, I, O, U. They have to be in quotes. And so they will be assigned to this vowel. The vowel will be automatically of size 5. It will be declared to be size 5, and these values will be stored. So let's see another example. Int num7 equal to 15, 20. If I store only 2 numbers, it will store those 2 numbers in the first 2 cells, and it will store 0 everywhere else. And if that's what you want, you can do that. So if I want to declare an array and initialize all of the memory cells with 0, I can do that by doing this. Because now I'm saying store a 0 in the first cell. If you store any number in 1 or 2 cells, the remaining cells will be set to 0. So by doing this, I'll be setting all of them to 0. All right, this example is not necessary, not important. So that finishes 6.1 and 2. 6.1 and 2 is basically all of that, understanding arrays. 6.3 is where we are going to actually use arrays. So we will do that in the next class. We completed 6.1 and 2. And I may want to add questions to the homework on 6.2, not 6.1, just 6.2. But I may or may not. So if you, right now there's nothing in chapter 6 in the assignment, but later I may add it. So if you're going to do the assignment early, just make sure you check with the link again to make sure there's nothing on chapter 6. I'm not sure whether I want to add chapter 6 or not. So check again before submitting to make sure there is no chapter 6 questions. All right, so we'll quit here, and everybody enjoy the rest of the day. I will see you Wednesday.
Thank you.
Thank you. Bye now.
So I have a question. For the references, are they always written before the main?
You mean the and symbol?
Yeah. Do I have to always before the main?
And symbol has to go before the name, yes.
Okay. Thank you.
Professor, I have a question.
Yeah.
You said you wanted to meet with me at 2 o'clock.
Yeah.
Are you free right now to talk?
Yes. So let's wait for everybody to leave. Yeah, you can wait.
Me too, Professor.
I'm sorry?
I said me as well.
Oh, you need to talk to me too? All right. I can only talk at one person at a time. So let me stop sharing this And all right, I'm going to have to, Natalia, I have to move you to the waiting room. All right.
Okay.
For now, I'll admit you later.
Okay.
Okay, Professor. You said you wanted to speak to me about an email that you sent, but I didn't get an email.
Yeah, you said you didn't get that, right?
Not on my Gmail or John Jay account, no. And you say you sent it on Sunday?
Yes, I used the your name to find the email address at the John Jay email box. So it should be John Jay email that you should get it at.
Well, I did not get it.
All right, I don't know what happened. Anyway, the point is this. I know all about that YouTube video that all of
YouTube video, Professor?
yes, YouTube video of me presenting the exam. And so many problems in the exam were on the YouTube and you all watched it. And so,
You're saying that I watched the YouTube video.
yes.
Professor, did I not speak to you after class like last week to discuss with you what I got wrong and how I could change the answers that I got wrong? Because I was confused as to how I got them wrong.
Hold on, before you go on. I know this happened and I have proof of it. And if you're going to deny this, I have to take it further to the higher level and it can become a much bigger problem. I can make it easier for you and give you an alternate solution if you are going to be honest with me and not fight this, okay? Because I know I have the proof.
Can I ask for the proof?
Don't make it difficult for yourself and me.
I'm trying to be difficult, Professor. I'm trying to ask, what is your proof, Professor? That doesn't seem
I'll
very.
present it to the higher level when it comes to the inquiry, and that's where it has to be.
So I can't know what the proof is.
All right, it'll go to the higher authority for
I'm asking
inquiry.
you, I cannot know what the proof is, Professor.
No, I know I have the proof, and I can prove it to them when it comes to proving.
You have a way to prove that I watched a video.
Yes, the YouTube video. I know
Definitive.
it was one student who published that information using the media, and many of you got that message and watched that video. And watching the video is something I cannot fight against, but using that information during that test is illegal. That's why it's a violation. Okay. And
Is though.
so if I'm just going to fail you and proceed to submit this to the higher authority, then I wouldn't have called you for a meeting. I'm calling you for a meeting to offer you a chance to continue. If you agree that this happened and willing to find an alternative.
I'm just trying to. I didn't do this. I'm trying to understand if first of all, my grade was barely above 70. First of all, second of all, if I were to have cheated, why would I come to you after class asking Professor, "Hey, I got so and so wrong. Can you explain to me why I got so and so wrong?"
No, that has nothing to do with it. Yeah, you were wondering why certain points were not given to you, and anybody can ask that question. It doesn't matter whether they had the access to video or not. Now, there were actually six people who had access to that video, and I have the proof of that.
6 people in our class watched that video.
In this class, yes, in this section.
You have definitive proof of this.
Yes,
Professor?
yes.
Okay.
So you want me to go ahead and file the proof with the
No, I'm just saying, you know, I'm saying, right, you know, if you're gonna make a claim like that, I feel like, you know, like on what basis is the claim being made, you know?
I don't need to prove anything to you.
I'm the one being accused of cheating. I think I should know what proof is being presented against me. I feel like.
Right. You can compare the your answer to my answer. It's exact match. That itself is one proof right there. And I have other proofs too, okay? I can, programmers looking at program can tell what programs are identical. Even if you change variable names, the structure can be compared. And so if I file this for a higher authority, they will have other faculty looking at, computer science faculty looking at it. They will agree with me, okay? And you don't want to go that far. You can end up getting thrown out of school if it goes that far, okay? So I'm trying to offer you an alternative if you're willing to go along that way. Otherwise, I have to just
This is
pay.
alternate, Professor.
The alternate is this test grade cannot be used. Instead, I'll use the final exam grade in place of that because it doesn't represent your knowledge. All right.
I just want to know how do you definitively know that I watched the video?
I'm sorry. One more time.
I'm trying to know how can you tell that me on YouTube clicked on your video and watched it? I'm trying to figure out how is how
How? For one
it's
thing,
just not clicking.
you have exact answer I had last in the last test. I gave it to the last class in fall 20. That's the video everybody watched. The test discussion. Okay.
So are you saying, and how you know I watched this video? Because the answers are
Because the exact same solution I have on that video is what you have.
so the ones I got correct were like the ones in the
Got
video.
correct, yes. The other ones, you had the same idea, but you made mistakes. You had the right idea that I used in the programs, but you made mistakes and lost points. But you had all of them. You had access to all of them. That was very clear.
My thing is, right, I never really understood that concept, right? Let's say a student, right?
Yeah.
Studies hard, takes a test, right? Gets the answers right.
Mhm.
But a student who mind you hasn't cheated, right? Gets the same answers that they had on your test, right? Would you accuse that same student of cheating or no? If they were to get on
Because
their own the same answers that you got.
yes, because no two minds can work exactly the same way. If any program written by 10 different people will be 10 different programs.
10 different programs?
Yes, because they cannot be identical. The minds work differently, and there are a program can be written in 200 ways. 200 different versions
I
can be
don't think you could prove that definitively though, because people have example in class.
Right.
I've seen.
No, there's no point in arguing about this. Okay, I have everything I need to prove the case, and if you want to go that path, I can take that. Is that the path you want to take?
What are the paths again?
The path you can take is me going ahead and filing plagiarism report to the vice president's office, and they will start an inquiry. And if they conclude that it happened, the penalty, my penalty is fail, and their penalty is on top of that, whatever they want to do, and it can be throwing the student out of school. Okay, that's the maximum penalty.
What is the other path?
The other alternative is this test will become void, and final exam grade will be used in place of that.
Okay, Professor, we could use the final exam grade instead of this, Professor.
All right. Okay, I'll do that, and I'll void this test grade. So for now, it'll be showing a 0, which is not accurate because later it'll be replaced with the final exam grade. Okay.
All right, Professor.
All right.
And you're positive that I watched this video.
I'm sorry. One more time.
Never mind. Just forget it. Forget it.
I'm giving you an option.
I know. It's just.
All right.
I just think your logic is flawed, but
You don't think what?
it's fine, Professor. It's fine. There's nothing I can do about it. Just I picked the latter. I picked the voided test grade, the final one. This one.
Okay. All right, then you can log out. I'll admit the other one.
Okay, Professor.
All right. Bye. Hi, Natalia. You wanted to speak to me?
Yes.
You got my message, and I did see you sent me a reply asking for another meeting.
Because I never got the first meeting at all. I never got an email and saying about any meeting at all. And I feel like how you said to Brandon in class, you never mentioned it to me at all in class either. So I feel like that was not fair.
Yeah, I didn't mention it in class. Because I didn't want to bring it up.
But you did it for Brandon. So I feel like that's not fair, equal opportunity here. Like you didn't give me a chance at all.
Okay. All right, so here's what I can do. I can offer you an alternative to giving you failing grade and reporting to vice president. All right, you want to take the alternative?
No, because I don't want to go through all of that because I didn't do anything. And I don't know what proof you have of me doing something, but I didn't do anything.
The video, it's unfortunate that the video went viral among some students in the class. I didn't realize there is access to that video, and about 6 students had access to that, and you were one of them.
Yeah, I seen the video, but I did not use it during the test. There's no possible way I can use it during the test and still be able to hear what's going on in the Zoom. I cannot do that. I seen the video. I use it as a reference because I had no idea if it would be the same test or not. I use it as a reference to study.
You had the video or the screenshot available during the test. That's what I see. Okay.
Where did you see that?
Well, I don't need to prove anything to you. If you want me to prove this, I will prove it to the vice president. You want me to go that direction?
Can I just drop the class? Is that another alternative that I can do?
Okay, if you want to do that.
Okay, how do I go about that?
You just have to, you can do it online. I don't know, I was never a student in John Jay, but if you just search top class at John Jay College, you can find that link. And you just have to, it's a JSTOP. That's what the station is called, where you can go and do these things in person. That was when students were going to college in person, but now all that is done online. So
because this is my first semester at John Jay. I only been to, I don't know how the CUNY system really works. I only been to SUNYs, so I don't really understand.
yeah, it's you can drop online. I don't know exactly how, but if you search top a course John Jay or something like that in Google search, you should be able to find it.
Okay.
Okay. The name of the service is JSTOP. I'm sorry, JSTOP. and maybe you can search for that.
Okay.
So you don't think you can handle this if I allow you to continue?
I think I can. I've been studying really hard. Like this is something that I've been really wanting to do. But if you're not trying to do that, then I'm just going to drop the class because I don't have time to put this on my transcript. Like I don't want a failing grade on my transcript.
But yeah, yeah, there's a chance that you can still end up failing, and if you don't want that, then yeah, you can drop it. All I can offer is, in place of this test grade, I can use final exam. That's the only offer I can make. And so that means whatever the grade you get in the final exam is going to dominate your grade.
Okay, so you're saying the final would matter more than any other test?
Yes, it's going to matter for the second test also. The first test, you have a failing grade from
Yeah.
yes. So it puts put all the pressure on you for the final exam. If you fail the final exam, you fail the course, basically.
Okay. All right then.
Okay, so what do you want to do? Anything?
Can I just have some time to think about it? Like I'll like by the end of the day.
All right. Okay.
Okay. Thank you.
Bye. Amy, did you want to speak to me?